Passamos agora à segunda palestra.
We'll now hear the second presentation of the day with the topic fishery research, management and stock evaluation, the role of science in the Northeast Atlantic. Nina makes up with the Arctic University of Norway.
Okay, can you hear me? Am I on? Okay. I'm a fishery scientist from the Arctic University of Norway, which is the northernmost university in the world, actually. Next. This is just an outline of what I'm going to talk about today. Go back. Go back. First, I will give you a brief introduction about what our waters are and what species we have in the waters. Then I will tell you why do we need knowledge, why is it so important, how do we obtain knowledge, and how do we implement it in the management. So Williams told you this. Norway is way up there. We're the second most largest seafood producer in the world, even though we're a tiny, tiny country. But as you can see, we have ocean in the north, in the west, and in the south of the country. Next. So in the north, we have the Barents Sea, which is a pretty shallow shelf sea. It's about 230 meters depth in average. In the west, we have the Norwegian Sea, which is 3,000 to 4,000 meters deep basins there. And we have the long coastline, which is very productive and warm because we have the coastal current of the Gulf Stream coming up with warm Atlantic water. So even though we're very far north, our sea is not that cold as it would be other places in the world. In the south, we have the North Sea. It's a shallow sea. It's about 100 meters deep. And it's very affected of human activities. It's fisheries, oil and gas exploration, pollution, and we have climate change all over the place. Okay. This is a typical fjord in Norway. And these fjords, we have a lot of them. And they are very, very important for the local fishermen with the smaller vessels. We also have local stocks of both cod and herring and other species inside this fjord that don't go out. The trawlers and the purse-seiners are not allowed to fish in these areas. Those are reserved for the smaller fishermen. A big trawler in these fjords will deplete the stocks very fast. So they can't fish there. So these areas are restricted by gear and vessel size, as well as the quota for the quantity. Yep. This is the historical Norwegian fleet fishing in Lofoten, like you once said. They were fishing for cod, very, very important fishery in Norway. Next. This is how most of these small coastal vessels look like now. They're fishing with gill nets, hand line, long line. Next. While out at sea in the ocean, we have the big guys, the trawlers, the purse-seiners. This vessel is called Hermes. It's from my city up in Tromsø, far north. This vessel has a quota from 8,000 to 9,000 tons of whitefish every year. In addition, they have shrimp. They fish all year round, all season. Next. And again, this is the cod, just telling you how important it is. It's the most valuable, both in quantity and value in Norway. But we also have other important species. Next. For us, we have the haddock. It's also a bottom fish. We have the saithe that goes a little bit in between. It's also whitefish. And we have the mackerel, herring, and capelin that are pelagic fishes. The capelin is a short-lived species, about this size, maximum size, 24 centimeters. It varies a lot in stock abundance, and it has a short lifespan. You never find it more than 5 years old, usually not more than three or four. When it matures, it spawns the next year and it dies. So it dies at after spawning. So that's a vulnerable species. If you have a short-lived species, if you have 1 or 2 bad years of recruitment, the stock will collapse or have a problem. That's very difficult for the management. So that's why we're kind of extra careful with those species, that you need to pay attention. If you have a short-lived species, the chances of depleting the species is much higher. Yep. And here are the landings of the catch in Norway, the total catches and the value of the catches in your currency, the blue. So last year we had a 7.7 billion in your currency landed value of the wild fish. This is not included with the farming. Okay, next. So how do we regulate this? This is, Johan is going to walk you more through this, but this is where the science kicks in, science. You see, we are there, we're collecting data, we're monitoring, and we're building models, and we try to look at the species interaction and the ecosystem approach in the science. We give our data and advice and models to an international ICS system, which comes with a quota, and there it goes from the government and Johan's presentation later. Okay. In Norway, it is the Institute of Marine Research that is responsible for monitoring and assessment of the fish stocks. But in addition, we have all the other universities and research institutions that do science on other things that we kind of incorporate after a while. So I'm not at the Institute of Marine Research, I'm from another university, but our research go into the considerations. So when I'm working on a food web model for the ecosystem, my results will be taken into account if they are important for the species. Okay. So why do we need the knowledge? Most important thing with knowledge is the future, the sustainability. Okay, next. So here is a young fisherman. If we want the next generations to be able to fish like we do, if we want them to have food, we can't empty the oceans. So we have to fish in a sustainable manner. This is a picture of a really big coastal cod. It's not from the Barents Sea. Yeah, next. So we had our problems, as indicated earlier. We had our problems and failures in Norway as well. We depleted and overfished some of our stocks, and we learned a lesson the hard way. The fishermen were bleeding in their economy, and the scientists were bleeding in their proudness. It wasn't a funny thing. We had the single species models the whole time, and we were not considering who is eating who. And if one stock is high and the other one is low, and one is feeding on the other one, this one will have an even worse case. So how do we balance things? So we realized we have to take into consideration the whole ecosystem and the multi-species. Another thing that we knew that we needed knowledge for is the distribution of the species and where are the juveniles that we want to say. We don't want to fish our juveniles because we want the recruitment for the next years to come. So both the fishery statistics and the research vessels have information on where we can find the juveniles. So the fishing vessels report to us where they do catch a lot of juveniles, and they have to. If it is too much, we have a quota and we say that this many percentage you can have a bycatch of non-target fish or juveniles, undersized fish. If you are above that level, we will close that area temporarily. Those are the red squares there. Those are temporarily, this is from 2005, I think. So in April 2005, they closed those areas that are the squares. You could fish other places. But the red ring there, around Bear Island, there is no trolling ever. That's a permanent closed area. There is always juveniles there. Don't fish there. It will deplete your stock. Next. Another thing we've done is to improve gear technology, to increase the selection in our gear, to fish what we want, to try to avoid to get the juveniles in the first place. So in the Barents Sea, it's not allowed to fish with a trawl without having a sorting grid. This grid in the cod end of the trawl will let out the small fish. Okay, next. Another thing we need to pay attention to is the alien species and invasive species that we get caused by the climate change and ballast water. If the big vessels release their ballast water and it's not treated, they will sometimes add invasive species to our ecosystem. This crab was intentionally introduced to the Barents Sea by Russian scientists in the 1960s to improve food availability for people. People needed more food, so they put it there. It established, and it grew, and it grew, and it grew, and it entered the Norwegian waters, and now it's a lot along the northern Norway coast. We also have another one that is probably there due to ballast water. It's called snow crab. It's also very valuable, but it is affecting the ecosystem, and in the eastern part of the Barents Sea, we're now seeing signs of changing in the bottom community due to this crab. Yep. Here's another problem with a new species in your area, fishing area. This fisherman was fishing for lumpsucker and cod with his gill net. He doesn't have a quota for red king crab. His gear is ruined. He's in problem because he got a catch that he was not supposed to. So again, we did science on gear technology and the overlapping distribution. It seems that the red king crab is in the shallow water and in conflict with the gillnet fishery in the spring. So we try to avoid to feed in those areas. And in addition, the fishermen that had to move from some areas where there were a lot of red king crab got the crab quota. So the crab quota was given to the fishermen that was affected the most by this alien species. Now we were lucky because these crabs are valuable, but not all invasive species are. So we need to keep control of them and how they will affect the ecosystem. Next. Another thing, climate change. This is a global problem that we need to address. This is an example of how it's changing the Barents Sea. The Barents Sea is warming up. The Arctic species are going north where it's colder. At the same time, their zooplankton, their prey, which is very fatty, is decreasing, while another zooplankton species is increasing a lot. Then it's more food for the cod. So the cod is moving north. It's farther from the coast at some point, but it's more of it. It's growing. So the cod stock is very healthy, and it's not negatively affected about the climate change right now. It could be because a high temperature will increase the mortality in egg stage at some point. Right. So, what determined the stock size? In this big box we have a stock. What goes in is the recruitment and the growth of the stock. What goes out is the mortality, the natural mortality, fish eat fish, and whales eat fish, seal, seabird, and we have the fishing mortality. We need to be able to control these 4 factors to be able to say something about how big is the stock, how much can we fish, how much will the stock be next year. Right. So first, the recruitment. These are herring eggs. We need to know the mortality in the egg stage. to be able to kind of say, if the parent stock is this big, how much do we think that we will get out of it, of offspring? So we need to know something about the fecundity of the species, and we need to know something about the relationship of the stock, of the spawning stock, and the number of offsprings, right? So this figure just shows that on the bottom line here, you have the parents, and up you have the kids. And the red curve here, you can see that it's growing. The only certain thing here is if you have no parents, you will have no kids, right? And when it increases, it comes to a point where it's on the top, and then it goes down again. Even though the spawning stock is really big, it's going down. That's because of food availability for both the parent stock and the offspring. It could be bad spawning areas. And in some species, the parents will have cannibalism, so they will eat their offspring if there are too many of them. So for this particular stock, we have the precautionary approach to have a sustainable fishery. So we say we don't want to go down to this SSB limb. That's where the recruitment starts to fail. So to be sure to not go there, we put another arrow bar here. It's the SSB-PH. It's the precautionary approach limit for the spawning stock. So we ensure when we set the quota that we're not going to pass that SSB-PA. We have to sustain the spawning stock above that to be sure not to go down to the place where we can have a recruitment failure. Next. And this is exactly what happened with the capelin stock in the Barents Sea. We had 3 collapses in the stock here. They are caused by recruitment failure. If you see the bars here, that's the recruitment. And you see when they fail, there's not a lot of recruitment. That's not caused by overfishing. That's natural. The first thing that happened, the first really big collapse, we had a record high recruitment of herring the year before, or 2 years before. So the young herring was just depleting the total amount of capelin larvae. They just vacuumed the whole ocean. So great for the herring, really bad for the capelin. We need ecosystem approach in our management. Right. Next. Yeah, the recruitment failure. Next. So another thing that adds to the stock is the growth. In our areas, we have distinct growing season. They don't grow much in the winter. You have a slightly different problem. It's not that clear. But when they have growing seasons, we have this bone in the ear for the bony fishes that we can take out. We can actually see how old is the fish. We can count these rings like in trees. Next. So here's an example how we determine the age of the fish from the otoliths and also estimate the growth between years. The growth will be affected of the prey availability and the temperature as well. So if you have a cold year or years, the cod will grow slower. Now we have warming of the area. It's growing fast, as long as it does have enough food. Right. And here's one of the growth models that is mostly used. It's called von Bartholomä growth equations, and those are students should have seen this. You have the age, yeah. Go back. You have the age on the bottom line and the length up here. And as I said, fish grow all their life, but at one point they invest more in reproduction. So they still grow a little bit, but they're going to a maximum limit. Right. Next. Then we have the natural mortality. In the Barents Sea, we have a really large sampling effort and stomach sampling of fish to be able to know who eats who. And that's really important. When we're going to apply the ecosystem approach, we need to know how the food web is working. Right. Next. And the next very important thing is the fishing mortality. We have statistics on the fishing mortality, and the fishermen also measure the length, so we know which age group and length group they are actually fishing on. So which part of the stock is taken out. Right. Next. Another important thing, especially when you fish with trawling or shrimp, you will get bycatch of some non-target fishes. We need the data on these fishes as well. So the trawlers and the vessels have to report to us how much is the bycatch, because these are also in the ecosystem. We need to know how the ecosystem is working and who is going out and the mortality of these guys. Right. So how do we perform? We collect data, we assess by models, and we have an international collaboration because we are sharing our resources with other coastal states in Europe. We have Russia. We have a really good collaboration with Russia. We have yearly been conducting research surveys in the Barents Sea for many years. And we have the EU in the Northern Sea. So here's an example of some of the research vessels actually located from my city. The bottom one we use in the assessment of the red king crab. The upper one is one of 4 or 5 vessels that take part in the ecosystem survey in the Barents Sea 2 times a year. And the small one we use for the students to teach them fisheries biology. So we go out at sea with the students and teach them how to do the stuff and what goes into the models. They also go on the other cruises, the other vessels when they are available, but they have a different job as well. Right, next. So here's an example of what we're doing on a research vessel. We're going over an area. We have the echo sounder who's detecting the fish and dependent on the swim bladder. They have different echoes, so we have an idea of which fish is down there, even though we're not seeing it. But to be sure, we are trawling afterwards. We go over an area, we do the acoustic registrations, we trawl, and then we take the samples. Of course, we identify the fish species, and we take the samples for length, weight. We take out the otholates if it's a bony fish, and we do the stomach analysis. And these things are also applied, those 4 things, for next, for the reference fleet. Now, the reference fleet is a brilliant idea in Norway. The reference fleet are commercial vessels that are contributing to our research. So they get their quota, but then they get an extra quota to do research. Of this extra quota, they will have about 50 to 60% of the quota will go to a vessel owner. The rest will go for the science, for the sampling program. We put scientists on board and teach the fishermen how to do the sampling. But they also need to have a really detailed registered logbook on all their fishing activity throughout the year. So they have to log where they fish, how much, the size, the length, the weight, and sometimes they do have to take the stomach samples and the ear bones. We have different stock assessment models for different species. We also have data poor species in Norway. We also have species that don't have the ear bones. Then we have to use other things, like, for example, the shellfish, the shrimp. We have length frequency. So we measure a lot of frequency, a lot of shrimps. So we can use that. We have the surplus models that you get the maximum sustainable yield. There's a place to start, but you do need fishery statistics. You do need the landings. Yep. And here's just an example of how the advice from the scientists can go to the management. This shows the recruitment. This is Northeast Arctic cod. This is the recruitment on the top. Then there's catches. We have the spawning stock biomass, and we have the fishing mortality. And this is done so the managers who are not biologists or fishery scientists should be able to see what is going on and how much risk are we willing to take if we're getting close to the limits. Because that's not the scientist's job. We just say that here's the scenario, here's what you can do. You decide. And they decide together with the fishermen. They have meetings and negotiations. Next. Then the last thing, the universities do have to cooperate with international projects. And my university is attending to several EU projects. They're funded by the European Union, even though we're not a member of the European Union. But it's because we have a lot of fish and a lot of waters. So the Climefish project is basically seafood production under climate change. So take into account the climate change. We try to monitor and make projections of what is going to happen when the climate is changing, both in aquaculture, in marine fisheries, and in freshwater fisheries. And we have 7 case studies, different places in the world, and we do have a partner in Chile on this particular project. The Farfish project also aims to improve the management of the EU fleet who is fishing in the high seas outside of Europe. They have a partner in the University of Sao Paulo, because one of the case study areas is FAO Area 41. It's out here. And Frame is just closing up. They are trying to remove the barriers for implementing the ecosystem approach. We all know we should do it, but most places we don't. And Pride Fish is a project that is focused on marketing. Next. So this is the Climefish. There's a folder right there. Here, Farfish, just showing where Norway and Brazil are partners in this. And yeah, I just said the Farfish output. And also important, all these projects need to cooperate. So when you figure out something in one EU project, we're supposed to use it in another project. And these things are open and available for you as well. Right. I think that's it. Yeah.